Every time you ask an AI a question or generate one of those cool images, it feels like magic, right? Like it's all just happening in some digital cloud. But what if I told you that every single one of those clicks has a real physical cost, a cost to our planet? Yeah, let's dive into AI's hidden carbon conundrum.
I mean, we think of these AI answers as just appearing out of thin air. They're clean, they're weightless, but behind even a single sentence, there's this massive chain reaction of calculations, and every single one of them burns real energy. So it really makes you wonder, doesn't it? What does that instant answer really cost?
Okay, to put this in perspective, just think about this number: 2,000 homes. That's how much electricity a single large data center can burn through. We're not talking about a small operation here. Imagine an entire suburban neighborhood, all their lights, all their TVs, their refrigerators, everything. That's the power we're talking about for just one of these AI powering buildings. Suddenly, that abstract idea of AI becomes a very, very real and very power-hungry thing.
All right, so let's really get into it. We're going to pull back the curtain and look at the massive, unseen engine that's running all this AI and really start to understand the scale of the problem.
Okay, first things first, we have to get rid of this idea of the cloud. I mean, it's a brilliant marketing term, right? But it's totally misleading. AI doesn't live up in the sky. It lives right here on Earth, inside thousands of these enormous, warehouse-sized buildings that are just packed to the gills with computer servers. We call them data centers, and they are absolutely ravenous for power.
And we're not talking about some small-scale thing here. Just look at this map. You can see how these data center hubs are just popping up and expanding all over the country. This is real, physical infrastructure, and it's concentrating this almost unbelievable demand for energy into very specific spots. We're talking places like Data Center Alley out in Northern Virginia, or massive hubs near cities like Chicago and Dallas.
So now that we know where AI lives, let's talk about its incredible thirst for power. And trust me, the scale of it is pretty shocking. So what happens when you have this sudden, massive surge in electricity demand? Well, it puts a huge strain on local power grids that were never built to handle this kind of load. So utility companies are forced to rush these really expensive upgrades. And guess who ends up footing the bill? Yep. A lot of the time, those costs get passed right on down to local residents, showing up as higher utility bills for everyone.
But here's the really wild part. How are utilities even meeting this demand? You'd think it would mean a faster switch to renewables, right? Nope. In some cases, they're actually being forced to delay shutting down old, dirty power plants. It's this crazy contradiction, isn't it? The super clean, futuristic world of AI is literally being powered by keeping old-school coal plants online.
And it's not just about keeping the old plants running either. The demand is so intense, it's actually fueling a whole new construction boom for natural gas power plants. Plants being built specifically to service these data centers. And that risks locking us into decades more of dependency on fossil fuels, all to power the AI revolution.
Okay, so that's the problem. And it's a big one, it's complicated, but this is where the story gets really interesting. What if the solution to AI's massive energy problem was actually more AI? Yeah, let's dig into this digital double-edged sword.
This is the central paradox right here. On one hand, you've got AI data centers straining our power grids. But on the other hand, AI itself, the same technology, can be used to make that exact same grid smarter, more stable, and way more efficient. It's the problem and the solution all rolled into one.
And the potential impact here is just huge. So take wind power, for example. Its biggest weakness? It's unpredictable, right? The wind doesn't always blow. But what if you could predict it with incredible accuracy? Well, using AI, we can. And by doing that, we can make wind power up to 20% more valuable. Suddenly, it becomes a much more reliable, much more essential piece of the energy puzzle.
And that's the key thing here. We don't have to tear everything down and start from scratch. AI can work with the power grids we already have. It can automate them, optimize them, and make it way easier to plug in renewables like solar and wind. It helps get rid of all those energy-wasting bottlenecks and congestion in the system.
But it goes even further than just managing the grid. AI is also becoming this incredibly powerful tool for invention itself. It's offering some real hope that we can forge a greener future by speeding up the exact scientific breakthroughs we desperately need.
And this is where things start to sound like science fiction. I'm talking about AI in the lab, sifting through scientific data sets that are just too massive for any human team to handle. It can predict the properties of materials that haven't even been discovered yet. It can even run experiments in these automated self-driving labs. All of this is dramatically speeding up the search for game-changing materials, things for better batteries, for more efficient carbon capture, for new synthetic fuels.
And this impact is just so broad. We're seeing AI being used all across the clean tech world. It's making the manufacturing of solar panels and batteries more efficient. It's helping us design smarter buildings that waste less energy. It's even helping to cut emissions in really tough industries like cement and steel. It's optimizing the entire clean energy supply chain from the very beginning to the very end.
So you see this incredible tension, right? On one side, AI is this massive energy hog. On the other, it's a potential climate savior. And that brings us to the core dilemma of this whole thing. How do we solve this carbon equation? Now, you might be thinking, well, the obvious solution is to just make the AI models more efficient, right? And you're not wrong. There's this popular technique called model compression. It's a bunch of clever tricks that basically shrink the AI down. Things like pruning away parts it doesn't need or quantizing data to make it simpler. The goal is a smaller model that uses less power. Sounds like a perfect fix, doesn't it?
One of the coolest techniques is called knowledge distillation. You basically use a big, powerful teacher AI to train a smaller student AI. The student learns to do the same job, but with just a fraction of the resources. I mean, it sounds like the perfect answer, but there's always a catch.
And here it is. In this really surprising study, researchers found that one of these smaller, more efficient models can actually pump out up to 6 times more carbon emissions than the big original model if you run it on a dirty coal-powered grid. It's a total shocker. It turns out that how you power the AI is way more important than how small you can make it.
This is a classic example of something called the rebound effect. It's simple, really. Think about it. When your car gets better gas mileage, you tend to drive a little more, right? When a technology gets more efficient and cheaper, we just end up using it a lot more. So the huge risk here is that any energy we save by making AI smaller gets totally wiped out by a massive explosion in how much we all start using it.
So what's the answer? How do we manage this? Well, it's a big enough question that global institutions are already trying to figure it out. The IMF, for example, has floated a pretty direct solution. Just tax the carbon emissions of AI servers. The idea is to build the true environmental cost right into the price tag of the technology. That way, companies have a real financial reason to seek out cleaner power.
And that really brings us to the final and most important question. AI is, without a doubt, one of the most powerful tools we've ever created. But at the end of the day, it's just that, a tool. Its destiny isn't written in stone. So the real question isn't about the tech itself. It's about us. It's about the choices that we're going to make. How are we, as a society, going to choose to balance AI's incredible power with its very, very real planetary price?
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.